Hello, everyone. Thank you for joining us for the ISC web seminar on IPv6 for the enterprise. My name is Larissa Shapiro, and I am a product manager here at ISC. This seminar is the third in a series on IPv6 that ISC has been putting on this spring, and we're going to focus on the needs of enterprise networks. Joining me today to talk about IPv6 for the enterprise are two of my colleagues, Suzanne Woolf, who is a manager of strategic business partnerships here at ISC and has been very involved in following IPv6 protocol development and deployment, and Alan Clegg, who is the lead trainer at ISC and also a support engineer here, and he trains on IPv6 as well as bind and DHCP. So let's see here, just to get us started, a little agenda check. Introduction is what we're doing now, and then we're going to do a strategic overview of why you need IPv6 for your enterprise network and some initial assessments you can do to figure out where you need to go first. Then we're going to get into some tactics, what it actually means to support IPv6, and some discussion of IPv6 and basic services and how to get there. At that point, I'll talk a little bit about how ISC can support you in your IPv6 deployment, and then we will take questions at the end of the hour. So just a couple of WebEx logistics. The presentation is about 45 minutes long. You can send questions at any time. You can send them to either the chat or the Q&A window, but I find the Q&A window works better. It's easier to see your questions there, and I'm less likely to miss them. And I will moderate a question and answer session with the panelists at the close of the session. All of our slides and WebEx audio archives for this and all of our webinars are available at this URL right here within 2 business days of the web seminar. So if you missed our previous 2 IPv6 sessions, you can check them out there. So just a quick word before we get started on our content today about ISC, who we are and what we do. ISC stands for Internet Systems Consortium. ISC is a nonprofit 501c3 public benefit corporation. 501c3 is a tax designation for public benefit nonprofit organizations in the United States. And ISC is dedicated to supporting what we like to call the infrastructure of the universal connected self-organizing Internet, which is a really long way to say that we believe that the Internet belongs to everyone and not to any specific agenda, be it corporate, governmental, political, and we believe in the autonomy of all participants in the Internet. And the way that we support that is by developing and maintaining production quality software, protocol, and operations. So a few of the things we actually do, we develop open source software. Most of you are well aware of our bind product. That's a DNS implementation. According to recent surveys, that's on about 80% of the name servers in the world. It's a very widely used application. We also have a DHCP implementation, ISC DHCP, that's quite widely used, and several other pieces of infrastructure software, And we are in the process of rewriting our DNS and DHCP implementations for the modern computing era. They're several years old now, and that product that we're working on is called Bind 10. We had a session about it a couple of weeks ago, and you could check that out on the webinar archive page. All of our software is backed up by ISC's professional services. So we have a support organization that provides professional technical support 24/7. We have a training program, which is as I mentioned, Alan is our lead trainer for our training program, and we train on bind and DNSSEC, DHCP, and now on IPv6 fundamentals as well. We do those trainings publicly all over the world, and we can also offer private trainings. We also have custom development, which is development of our open source project with specific customer needs that are directed and funded, but the code generally goes back into our open source products. And then we have consulting that we can help you with deployment or basically any any concerns that you have, audit, design considerations, rollout of IPv6 or DNSSEC or any protocol. Our public benefit programs include our FRoot name server, which is one of the root name servers of the DNS, and it's anycasted to, I think, over 80 sites worldwide. We have our hosted app program, which is public benefit hosting. That's for open source and other public benefit organizations. We have a very active participation among ISC staff on multiple internet governance and regulatory organizations, as well as protocol standardization organizations such as the IETF, ICANN, ARIN, network organizations. And one of the things that we do through those organizations and through our own work is protocol development. So ISC staff has been very involved in both IPv6 and DNSSEC protocol development. And another thing that we do here at ISC is security work, and we have a product that we call SIE, which stands for Secure Information Exchange, and that's a platform on which security professionals can exchange data about attacks, botnets, various security concerns, and they can view collections of aggregate data from other people's security feeds that they provide. So that's a really great service for security professionals. With that, I'd like to turn over to my colleague Suzanne Woolf, who's going to start us off with IPv6 for the enterprise. Thanks, Suzanne.
Thank you, Larissa, and it's good to be here. Good to see those virtual smiling faces out there. We're going to start in what I see the attendee counter still crawling up slowly because we actually started on time, but we will go ahead and it's all being recorded so that anybody can refer later to whatever they might have missed. We're going to start in a slightly different place than we promised, with the question of why IPv6 in the more obvious case, considerations for the carrier. Pretty much the entire internet has sort of gotten the memo. It was announced earlier this year that there's no more unallocated IPv4 address space. And for anybody who needs to grow a network, the reason why this matters is obvious. You need IPv6, which was created in anticipation of this situation, to sustain growth. There's still a lot of internet to do. There are many billions of people who aren't connected yet. There are many new services and devices and activities still to be invented on the internet, and we're out of the original address space. So we need to keep going, and the way we do that is by expanding into IPv6. The additional factor for large-scale operators that need to grow their networks and whose network connectivity is their product is that NAT, which we adopted as the long-term measure quite some time ago to expand the usefulness and extend the life of IPv4, after the first time we almost ran out of IPv4 address space, network address translation doesn't scale for core transit networks. So there are a great many networks that don't need any more IP address space, but if you do need more IP address space, more globally routable, usable in the core address space, there isn't any more v4. You have no choice about IPv6. Now, that leads directly to the question, though, of whether folks whose product isn't network services, whose product is based in a different place, who consider themselves enterprise networks, do you need to be concerned about IPv6? And the fact is you do. If you look at the industry, you look at the trade press, you look at what the white papers are being written about these days and so on, what you see is that enterprises need to be concerned about this also. And the first and obvious reason is for interoperability with carriers. Your carriers need IPv6, and you will too. A closely related reason has to do with interoperability with infrastructure services, about which we'll talk a little bit more later. But sort of the high-level strategic consideration is that you need to maintain connectivity with all of your outside suppliers, not just your vendors and customers, but also with social media operators, with outsourced services such as call centers and web services, everybody that touches your network is going to have to be looking at the same questions you are of interoperating with carriers and with you, which makes IPv6 a concern. Over the longer term, there's a slightly different set of considerations that does kick in, where it comes to be an advantage to adopt v6 and to be adept with v6. As you begin to see first new devices that will take advantage of IPv6, the abundance of address space, the somewhat finer-grained control you may have over what addresses do in an IPv6 network. And what you will start to see is devices that natively speak v6 and whose full capabilities can only be realized when you can use v6 to talk to them. A closely related consideration for that is new services. Over the long term, as people get more comfortable with v6 and with the abundance of address space, they're going to start inventing new ways of using it that are going to be much more useful in ways we can't imagine in a world where addresses are scarce. But first, we have to adapt. We have to learn how to use v6 over v4. To a great extent, IPv6 is just v4 with more bits. It's 128 bits instead of the 64 you're used to. That's many, many, many more addresses. But there are some additional factors that go into working with v6. And we're here to say, don't be afraid of these things, but do be aware of them. One major topic has to do with address management. It's going to be a little bit different. You will probably be able to get a large block of IPv6 addresses from either your carrier or from your regional internet registry or your national internet registry, because there are so many more addresses that it's much easier to hand them out. We will not be operating on scarcity in any imaginable time frame. But there are some different characteristics around managing v6 addresses. For instance, familiar old DHCP still works. There is a DHCP v6. ISC has written an implementation and supports it, and there are others out there. But there are also some features of v6 specific to address management, some auto-configuration features that you may want to become familiar with and may want to employ alongside or instead of DHCP. Inverse mapping for DNS and dynamic DNS may behave differently, given that you can't comfortably enumerate all the addresses you want to provide inverses for anymore. v6 address spaces are just too big. Subnet management, for the same set of reasons, becomes a little bit more of a challenge. There are more of them, and there are more addresses in them. So some of the straightforward ways of doing addresses when it was easy to enumerate v4 addresses become a lot more complicated when you have functionally more addresses and you quite know what to deal with. In addition, because there's no flag day, because we can't wake up one morning and say, we're done with v4, we're going to v6, there are some technologies and techniques that you're going to have to become aware of, if only because your carriers and partners will be involved with them, for transition from v4 to v6. Or in some cases, because of legacy considerations, because of cost considerations, coexistence between v4 and v6, maybe for quite some time. The initial scenario for moving from v4 to v6 was going to be dual stack, is what they call it, where the operator would use v4 addresses at the same time as v6 until the bugs had been ironed out and there was no more need for v4, at which point v4 would just be turned off. There are some limits to that, mostly that it requires v4 addresses as well as v6, and we just talked about how that's going to be difficult in certain scenarios. In addition, there are these concerns around interfacing with carriers, and what we have there is interfaces with carriers, but that encompasses all of the other network actors you interact with, your customers, your vendors, and all of your partners, all the folks you work with. The consideration we're going to start with, it turns out that there are going to be a lot of different pieces of your network you need to discuss and consider, and separate components that you can move onward with v6 in relatively separate paths. And one of the ones we're going to talk about here, Alan will discuss extensively, is moving your basic outward-facing services such as DNS and web and and email towards v6 compatibility. But before we do that, it's important to take the high-level strategic view and to look as broadly as you can at what the different components of your network are and what your v6 migration issues are going to be. So one useful abstraction, one useful way to think about this is to look at all of the things you need your network to provide and ask, what does IPv6 support really mean? Your vendors will say they support IPv6, or your customers will ask if your services are IPv6 compatible. But you really have to start looking at what does that mean. And internally, you can start almost anywhere. It depends exactly on what your most important issues are, what your most important services are. But one thing you're going to have to look at is your network infrastructure. All the boxes you take for granted because they just operate your network. Switches and routers, firewalls, load balancers, and you have to look very carefully at what your vendors particularly mean by saying that these devices support IPv6. Because, for instance, there are routers out there that will pass IPv6 packets, but that don't allow you the most direct control over filtering that you need, that you get with v4, that you take for granted with v4, and may not be able to work with quite so comfortably for v6. So there's a whole set of considerations. Look at everything you take for granted that your network infrastructure elements do, and look at whether those elements can be upgraded or replaced or reconfigured to do the same things or the same level of control over v6. A similar consideration is going to be with end systems, with desktops and servers. Modern operating systems support IPv6, most of them directly out of the box, because this is a need that has been foreseen for quite some time. However, the exact mechanisms by which v6 capabilities are configured and managed for each operating system do vary and are still evolving. This is one of the frustrating things that you may very well run into, is that the vendors are still learning just as their customers are. Many operating systems support dual stack. If you have v4 addresses to give your devices, and you may very well, if you use NAT and RFC 1918 address space, dual stack may well just work for you with your new block of IPv6 addresses. In some cases, you will end up looking at transition technologies that we alluded to before, the ones that are designed to operate in situations where dual stack doesn't work or isn't the most manageable way of doing things. And again, the question of whether you manage your subnets and you manage your address allocations with DHCP or with some of the new auto configuration techniques that v6 allows, whether those questions become something you have to consider, whether you've probably taken DHCP or static configuration for granted up until now. And you can continue to do that or look further at some of the auto configuration technologies that were invented largely to make things like renumbering easier. So you want to take that seriously, the possibility that AutoComp is a step forward. For applications, you're looking at much the same set of questions, but it's even more complex and even more critical. Many legacy applications don't necessarily take full advantage of the ability to be address family independent or address family neutral, and to not care whether the transport available to the system is IPv4 or IPv6. Many applications assume that an IPv4 address is what an IP address looks like. They may not look for quad A IP addresses from DNS. They may be limited to IPv4 in other ways, and you may not be able to control exactly what they do, and that becomes an issue of working with vendors on upgrades or changes. And that's the sort of thing, as always, that you have to plan ahead for. An additional variant on that is the question or the issues arising from internal applications, where you may have applications that were written for internal use, not for commercial use, where people have done very clever things with IP address literals to bypass DNS, to bypass other kinds of changes, and other kinds of network issues, people have often used embedded IP addresses as a configurable or even a hard-coded quantity. This is certainly a fine thing, except it does limit what's going on when the system underlying your application can see IPv6 network activity, but the application can't. And another set of concerns arise, and Alan will again discuss this in a little more detail, with your outward-facing applications, with the things where that you rely upon to interact with other network services and with your customers and partners and vendors. So all of these things have to be looked at for what their assumptions are about what an IP address is and what that means for your connectivity. There's also a set of slightly less obvious considerations. Once you've thought about your hardware and your applications, another consideration that comes up is monitoring and management. Monitoring and management is the thing nobody thinks about until something breaks. And of course, when something breaks is the last time you want to be discovering that you don't have the visibility into your IPv6 network activity that you do into your IPv4 activity. So this is something to be considered from the beginning. The concerns there include debugging, logging, all of the routine things that you take for granted, that your marketing folks analyze, that your network management people analyze, that people use for capacity planning. All of those things, you have to make sure you know what they're doing and that they're also looking at V6 activity as well as V4. Troubleshooting. If your tools assume that the only IP address is an IPv4 address, it's going to be difficult to use them as you roll out V6 to find trouble spots. And a consideration that is in some ways even easier to leave until you need it, security. One of the key lessons, one of the great opportunities with V6, one of the things we learned from V4 is that retrofitting security onto a network designed for other things is extremely difficult and in many ways doesn't work that well. So what we have here is an opportunity to design security considerations into your V6 deployment from the beginning. And a set of questions that arises includes NAT is currently used as a security feature. NAT was a necessity when in the era when we were first concerned about running out of V4 addresses, and V6 was not a consideration because it was still very much under development. NAT was a device and a set of techniques to extend the life of V4 addresses, and people made a virtue of that necessity, the ability to use NAT and change address spaces at a NAT boundary had some features that people have adopted into their security planning and management. The question, however, once you're deploying IPv6, you're probably not doing the equivalent of NAT. So the question is, what other things, what side effects of NAT are you giving up? And do any of them have security implications? A related question has to do with if you're running V4 and V6 side by side, and perhaps some of these transition technologies, you have increased the number and type of accesses available to your network. This notion of surface area has come from the security folks. And the question you have to ask yourself, particularly with respect to outward-facing services, is will more surface area include more vulnerabilities and more things to keep an eye on? Almost certainly it will. And the related question there is what happens when you're not using NAT, when you have a unified address space across your network. You get back one of the basic principles of the internet architecture. You get back the notion of end-to-end connectivity without having to change address spaces, without crossing NAT boundaries, which in some ways gets us back some of the better features we started with. There are applications that still don't work well over NAT, and application writers, network services writers still run into trouble with NAT. We can do away with all of that, but there are implications to it that also have to be carefully examined in terms of security. And perhaps new opportunities, but that new opportunities always imply new vulnerabilities. So that's sort of the tour at the high level. That's the strategic assessment that you need to make before moving on. And I am now going to turn it over to Alan to talk in a little more tactical detail about one of the components you'll have to look at, the specific area around transforming your outward-facing services for IPv6 interaction and compatibility. And so on to you, Alan.
Okay, thank you very much, Suzanne. I appreciate it. And hello, everyone. This is Alan Clegg, and as Larissa said, I'm the lead trainer at ISC, and I'm going to talk a little bit about where you can actually start with deploying your IPv6 capabilities. First thing is the fact that documentation is what I would consider actually sorely lacking as far as how to actually go about doing things successfully with IPv6. There's a lot of technical documentation, but not a significant amount of end user, what commands do I actually type on the, on my devices to actually make something happen. So what I'm going to do is I'm going to talk just very briefly about two pieces of documentation that have been presented to us by the U.S. government. NIST has come out with a document, the Guidelines for the Secure Deployment of IPv6. Can also be found as a special publication 800-119. There is a link to this, I believe, in the last two slides in the deck, which will be available, as Larissa said, online later. And then the second one is one that is produced by the FCC, which is Potential Impacts on Communications from IPv4 Exhaustion and IPv6 Transition. And this can be found by doing a search for FCC Working Paper number 3, dated December of 2010. So these items these documents are something that I would recommend as a place that you can go to get some information, some guidance from the U.S. government on what they are recommending. Now, if you are a part of a government organization, then you know that it is not just a recommendation from the government, but it is actually a mandate. Now, having said that it's a mandate, it actually is a mandate that is still in the future to deploy, and that is actually a very good thing at this point, because what we can see by looking at this graph, this is a graph that is produced by NIST. It is updated weekly, I believe, and this is a snapshot that was done May 1st. So it was done the very beginning of this week. And what it shows is 1,327 domains within the government, within the U.S. government, that were polled to see their IPv6 readiness. And of the 715 DNS servers that were checked, 46 of them were IPv6 capable. Now, I don't know whether this is actually reachable over IPv6, producing data, Quad A records. My guess is that it is actually IPv6 reachable. Of the 560 mail servers, only 2 of them were IPv6 ready. And of the 660 web services, and the definition of web services for this slide is port 80 and port 443. Only one of the 660 domains checked actually had a functioning IPv6 web service. So while it is a government mandate, it's still something that is taking a little bit of time to get some traction. So what does it actually take to get to IPv6 readiness? I'm going to talk about 3 specific items. I'm going to talk just very briefly about each one. We're going to talk about DNS, talk about email, and then something that I'm going to call web services, but it should actually be more of internet-based services. This is not just port 80 and 443 traffic. This is relating to other items as well. Now, the other thing that you must remember when you go out and you start deploying IPv6 is that you're going to need to look at doing this in-house and on outsourced platforms. So if you have moved some of your services into the cloud, make sure that your cloud provider is preparing for IPv6. This is something that is very important, something that I'm afraid is maybe being overlooked. It may be relatively easy to do deployment internally, but getting the traction in your providers of outsourced services may be a little bit more complex. A couple of very, very broad generalizations. One thing that we have to remember as service providers is that services and the users of those services are very sensitive to variations in the quality of connectivity. If you have users that are expecting immediate web page loads, or if they're doing a real-time gaming or anything online, and suddenly they are unable to get the same performance that they had yesterday, then they are going to be rather upset that this new impediment is in their way. Hopefully, with IPv6 basically being required now because of IPv4 exhaustion, hopefully we are going to reach a point that everyone is going to be using actually native IPv6 transit. I've actually been using IPv6 for a number of years, but I'm doing it over a tunnel. It's very obvious to me when I am accessing data over the IPv6 transit because it is significantly slower. My first hop on IPv4 transit is in the low tens of milliseconds. When I go to over my tunnel, the next hop of my IPv6 is somewhere in the range of 180 milliseconds. And that is something that is very, very obvious and will cause extreme grief to your users. We also need to remember that IPv6 connectivity is not going to be as good as IPv4 is now at the beginning of this rollout. We need to understand that IPv6 is relatively uncharted territory for a lot of organizations. It may work today. Somebody may come in tomorrow and accidentally fumble finger something, and it may stop working. So we're good about keeping IPv4 networks up and running. IPv6, we're not really comfortable with yet, and it's now going to be something that we need to work on more carefully and more closely. Make sure that you have good contact with your carriers and your providing partners. In this case, I'm talking about your upstream network provider, because if IPv6 connectivity goes away, you make a call to your frontline tech support on your carrier side. Is that frontline person going to know IPv6? Are they going to be able to escalate you? Because this will be something that people are going to consider critical. Make sure that your provider has maybe an IPv6 help desk or a number where you can reach an engineer that is actually comfortable and capable with IPv6. IPv4 is something that network operations centers, again, have been dealing with for tens of years. IPv6 is something brand new, and perhaps you might even call it exciting. Well, let's talk a little bit about some of these services that we're going to be providing over IPv6 and how we would recommend that you actually go about providing them. Well, the first thing is on your IPv6 authoritative servers, first of all, before you do anything else, make sure that you have IPv6 connectivity and turn on IPv6 transport to those systems. Publish a Quad A record for your authoritative services. Make sure that your registrar allows you to use IPv6 in your glue that they insert into your parent zone. Once you've done that, you will begin to see queries come into your name servers over IPv6 transport. They may be asking for A records, they may be asking for Quad A records, but it gives you the ability to actually begin to see IPv6 traffic without providing external services that are going to require IPv6 or IPv6 readiness within the application. Once you have that up and running, you can then begin to add Quad A records for hosts with IPv6 ready applications. Now, the thing that you really need to be careful of is do not add a Quad A record to a service that does not have its application ready on the IPv6 stack. For example, if www.example.com is an IPv4 service today and it's working perfectly, just adding a Quad A record for that name, for that label, does not necessarily make the web services and the other services available on that system available and visible through IPv6. So make sure that the actual product that's running on the server is IPv6 capable before you actually provide the Quad A records aiming at that service. Another thing to remember about DNS supporting IPv6 is that some of the transition technologies actually need DNS support. For example, DNS 6.4 relies on mapping of IPv4 addresses into a special subnet of IPv6 space. This needs to be something that is done in collaboration with the part of your organization that is actually deploying the transition technology. It has to be done at the same time. If it is not done, the transition technology is going to fail, and it's going to be one of those things that is very difficult initially to debug. On your recursive servers, you're also going to need to turn on IPv6 transport. As your customers, as the users of your recursive servers begin to get IPv6 connectivity, let them use IPv6 as a transport to those recursive servers. There are other special considerations as well with DNS supporting IPv6. Bind has one specific feature that allows an easier transition from IPv4 to IPv6, and that is the feature called Filter Quad A on v4. This is an option that if an incoming query comes in over v4, IPv4 transport, asking for an IPv6 address record, Bind can actually be configured to lie in response and say, no, there is no Quad A record, assuming that since this query came in over IPv4, there would be no ability for that end customer to actually get to the IPv6 service, so we lie in response, and that is an option. We don't like the fact that we're lying about responses, but if the same query came in over IPv6, we make the assumption that the end user is able to do IPv6 transport, and therefore we are able to give them safely the Quad A record. Moving on, thinking a little bit about the DNS implementation, Bind has had support for IPv6 for over a decade. The Quad A record and the inverses as needed there. Most other mainline DNS servers also have support for IPv6. We are, however, working in relatively uncharted territory. The information that we're using with IPv6, we're using code paths that have not been exercised fully because people haven't been deploying this type of service. So be aware that you may run into issues, and again, work with your vendors. All of the vendors should be prepared to supply IPv6, and we're here to help. Talking just a little bit about IPv6 support for email, email is going to depend on DNS. So deploy your DNS first, make sure that it's working before you even consider turning on IPv6 in your email services. Your inbound services are going to be live as soon as you provide an MX record that has as the R data something that resolves to an IPv6 address. So if you are ready to be supplying IPv6 transport for email services for inbound, all you need to do is provide the IP address or the IPv6 address as an additional record for the address of your MX, and magically it will start working. Something I've added as a bullet here that should be obvious, and often, unfortunately, we kind of forget about this, is internal testing must be done first. Whatever you do, don't use your internal customers, your customers within your organization as test dummies for IPv6 transport. Make sure that it's working in your lab environment before you go out and just flip the switch. Now, having said just flip the switch, it's very possible that email services are just going to work right out of the box. Most modern MTAs actually have support for IPv6 built in. Very often it is an option that is commented out. So all you're going to need to do to make your mail service IPv6 capable is take a single line or multiple lines in a configuration file somewhere, remove the comments, remove the hash mark or semicolon or whatever they use for a comment, restart the service, and congratulations, you're running an IPv6 mail service. Now, there are some issues surrounding spam blocking, that there are currently blacklists that use IPv4 addresses as an initial method to make sure that incoming mail is valid and is not coming from a known spam source. With the size of IPv6 address space, that does not scale well into IPv6 space. So something that is being discussed widely in the anti-spam and in the communities that are dealing with that type of issue is how to go about creating real-time blocking of IPv6 space when it is just as astronomically large as it is. One thing that I would strongly recommend is that you consider turning on inbound IPv6 email before you turn on outbound IPv6 email. If you turn on inbound, you're publishing a quad A record, the IPv6 address, for one or more of your mail exchangers. This allows people on the other end, people on the outside, who are actually capable and knowledgeable and have their IPv6 up and running and have transit to be able to hit your servers. When this occurs, you know that the person on the outside has actually been working on this and they are actually making an outreach to connect to you using IPv6 transit. The reason I would not do outbound initially is that outbound relies on the other person having configured their service correctly. If they have an IPv6 address for one of their mail exchangers and they have not configured it correctly, the initial delivery attempt of an email may fail. It may back off and be retried at some later time. And with the internet as good as it is today, with IPv4 working as quickly as it does, we are not used to having email stored and forwarded. That used to be the way it was done because we didn't have this global pure connectivity. But now everyone expects that when they hit send on their email, it's going to magically appear in the other person's mailbox almost immediately. If they have misconfigured IPv6 on the inbound where you're doing IPv6 outbound, you may cause a degradation of service for your customers. Now I'm going to talk just very briefly at a very, very high level about other web services, and this is the terminology used by NIST. When I'm saying web services, I am talking about not just port 80 and 443, but all of the other services that you provide over the internet. As Suzanne mentioned, one of the big problems is going to be the actual data that is sent over the transit. The issue being that if your data actually contains IPv4 literal addresses, for example, a dotted quad, 192.168.1.1, whatever your visible IP space is, if you, for any reason, have an incoming customer that is only able to use IPv6, then whatever that information is that is in that literal IPv4 address is going to fail. The same with names. If you have embedded secure.example.com and someone comes in over v6 transport to your www.example.com, when they do a lookup of the secure.example.com, are they going to get an IPv4 address or an IPv6 address, and are they actually going to be able to connect to that remote service? Additionally, we need to consider your external dependencies. Are your queries being tabulated by an organization, for example, like Google Analytics? Is Google Analytics going to be able to deal with an IPv6 address as the incoming IP address of the client? Your content delivery network, is it IPv6 capable? Advertising providers, you know, a lot of organizations basing revenue on, you know, advertising or analytical data retrieved from their web servers are going to be sorely disappointed when suddenly they get back statistics that say, well, someone came to see you, but we don't have any clue as to who it was, and you don't get any revenue because we don't know if they clicked or not because we don't have IPv6 infrastructure. Network quality is key. If you are deploying IPv6 at this point without having an upstream provider that is providing it natively, you may actually deploy a tunnel. If you deploy a tunnel, prepare for slower network access. Are your users going to appreciate it when that last hop is 100 milliseconds where they are used to seeing 10 milliseconds? Be aware of this. Make sure that you consider doing an incremental deployment. Right now, we really don't need to worry too much about people who are coming in from pure IPv6 network space. Right now, we're still going to be seeing dual stack. You're going to have people that are capable of doing connectivity over IPv4 if whatever service is not available over IPv6. But we are going to need to move to a pure IPv6 environment as quickly as we can. Some things to remember is monitoring. You're now monitoring your IPv4 connectivity. You're going to need to duplicate that effort and make sure that you are also monitoring your IPv6 connectivity. The complexity of your network. Routing on IPv6, while similar to IPv4, is not the same, and different things can break in different ways. And as I said previously, latency and performance are something that we're going to have to deal with a lot, because as we deploy v6, you may be using pure native transport, but the person on the other end may be using a tunnel. So you may be providing your web pages or your data stream at the same latency as you always have been over v4 or v6, but they are going to see it differently because now they are using v6 transport where previously they were using v4. So just something to keep in mind. And finally, just a few words of advice. You're probably going to care about IPv6 even if you are not out of IPv4 addresses, because people these days are going to be beginning to use IPv6. Whether you have all the IPv4 space you need or not, they probably don't. So you are going to start seeing a ramp up of IPv6. A lot of services actually prefer IPv6 addresses over IPv4 addresses. So if v6 connectivity is available, then it's going to be used. Don't panic, but do plan. We're all in this together. You are not alone. ISC has been doing IPv6 for quite a while. We are comfortable with the technology. We're comfortable with the routing. But there are a large number of organizations, and large number of large organizations that are still in the phase of, gee, what is this IPv6 stuff, and how are we going to actually make it visible to our customers? So be aware that you are not alone. And again, incremental deployment will get you where you need to go. You need to go in and begin or continue assessing, what does IPv6 support mean to you? Is it good enough to have a switch that is passing IPv6 data but is only manageable via an IPv4 interface? Begin to talk with your distributors, talk with your support organizations, talk with your vendors about what IPv6 means to you, and by what it means to you, what it's going to mean to them. Always, always be patient. We are going to have teething pains. We know that things are going to break. Everybody is aware of this inside the internet infrastructure. Be aware of this. Be ready. Our customers, our end users, don't have any idea what IPv6 or IPv4 are and how it impacts them. So they're going to see it as network outages. They're going to see it as other failures. We need to be ready to respond as quickly as we can. And with that, I would like to pass it back to Larissa for a wrap-up and then our question and answer session.
Fantastic. Thank you so much, Alan. So I think now you've got a good sense of what we're what we've covered and what you're facing inside the V6 space, at least the beginning of it. And I see we're getting a few questions already. I would like to ask that if you have questions, you start typing them now, and I'm just going to talk for a minute about some upcoming events that ISC has that you may find helpful. So 2 upcoming web seminars that we have. The first is a DHCP session on upcoming roadmap for DHCP and DHCP v6 in particular. So for people who are concerned about rolling out IPv6 in your enterprise, this may be a very interesting session. And we very much are hoping that we can poll the group and get some sense of which features are needed most urgently, because we know that there's some urgency around DHCP v6 for operators. So we're really hoping to see some of you there. And then if you're not tired of hearing Alan and I talk, we're going to do the second part of a 3-part series we've been doing on DNSSEC key management on June 1st. And that should be really informative. The first session was really great, and the first session is on our webinars page. There's an WebEx video audio archive, so you can check that out. We will also have more web seminars coming up. We're doing about 2 per month here at ISC at this point, and upcoming topics will include our new registry services offerings and a session on DNS Anycast, and we'll have other sessions too. So folks can stay tuned for those, and also let us know if you have sessions you would like to see, what you're interested in hearing from us about. We would be happy to cover any topics you're interested in. So just really quickly, we have several IPv6 trainings coming up. The first 2 are at nearly the same time in Redwood City and in Amsterdam, and those both coincide with World IPv6 Day, which is kind of fun. And then we have several more coming up throughout the year, and we can also do private trainings for your organization if that is something that is of interest. These are 3-day courses. I took the inaugural course myself, and I thought it was really outstanding. So we also want to make a set of special offers for people who are on this web session today or were on this morning's session. One of them is a combined package for an IPv6 training, seat, and consulting for your organization's v6 rollout. And the other one would be a combination consulting and bind support package. And you'll get an email with some coupon codes and further information about this after the session. So with that, I want to head over to questions because we're getting close to the hour, and I want to make sure everyone sees, gets the information they need. And the first one that I want to take is, okay, this came in earlier in the hour, and the question was, since routers can't possibly have enough table space to hold MAC translations for a /64 subnet, a sweep of the subnet address space, for example by a worm, can exhaust the allocated RAM. What strategies can you offer for dealing with an address scan? I don't know if Alan or Suzanne.
I can say a few words on that. Although I'm disappointed that all we can really say about that is that's one of the questions that is coming up. It is a question principally for the folks that are vendors of your networking gear. And I hate to pass the buck in that way, but the fact is that this is one of several areas where the simple fact of so much more v6 address quantity becomes a qualitative kind of difference, and people are still getting used to that. That you can't really, pardon me, that considerations of brute force are simply different with the size of the v6 address space. With that said, I know that the issue has been raised with multiple vendors and carriers particularly, you know, for the obvious sets of reasons, that they have very, very limited ability to filter what traffic is trying to make its way across their transport networks. That question has been raised with vendors. Perhaps the best advice for enterprise customers of those vendors is to add their voices to the chorus. This is also an issue we're keeping an eye on. you know, in general interest of deployment issues. But it's going to have to be solved by vendors realizing that the gear is just going to have to cope with the fact that brute force on IPv6 scales is a different problem than brute force on v4 scales. With that said, all is not gloom. There is interest in this. Folks are working on it, and it's one of the teething pains. It's one of the things we're going to have to work out over time.
Thank you, Suzanne. Okay, so the next question is, if you're considering inbound before outbound, theoretically speaking, when do we consider it safe to test outbound, assuming that no one has tested our inbound previously? Alan, I think you were asking for some clarification on this.
No, actually, I have an answer, and I'm going to follow up. I actually am going to talk just a little bit about a number of questions that this kind of raised, I think. Obviously, there are going to be people that aren't going to hear the little presentation here, and obviously are going to turn on inbound and outbound IPv6 email. I am one of those people. I very, very rarely follow the instructions that I give to other people. I am currently in my very small environment doing IPv6 email both inbound and outbound, and I'm actually having very good connectivity and very good results with it. If people do not have IPv6 capable email, they're not publishing Quad A records, and therefore it just magically works. Obviously, at some point, you're going to need to turn on the outbound, flood of IPv6 mail. What you can do is go in prior to, that point, do some statistics on, is this certain provider sending IPv6 email to me? If so, then I can look at their service and see if it's actually working in that direction, and do it manually, do it from the command line. Telnet to the IPv6 address, port 25, or port whatever the submission port is, and see if it actually works. And if it does, then I can begin to turn on the outbound email. So while I recommend for the first step that people not do both right off the bat, once you have it working one direction and you start seeing that the data is actually traversing the network correctly, then you can actually go ahead and turn it on the other way. Now, a second comment, and I'm going to answer another question that came in on that, is using IPv6 for just inbound email may have issues if there is no reverse DNS. So, for example, in a co-location environment. DNS is going to be a very interesting thing, and the use of it to qualify spam and non-spam is something that I think is going to have to be thought out very, very carefully in the as we actually do this rollout. There are a number of working groups that are dealing with this. The Messaging Anti-Abuse Working Group, MOG. I know I was there in the spring, or actually I guess it was earlier this year, sometime earlier this year, and they were actually having this very discussion of how are we going to do blacklisting of email or of addresses. How are we going to use inverse DNS to actually provide a validation of spam or not spam? And I think that is something that is still being worked on, and I think that we're just going to have to be a little bit more lenient at this point as to, I'm not necessarily going to be able to do a forward and inverse lookup of the IPv6 and assume that we're actually going to get good inverse data. I hope that answers your question. If not, feel free to type in some more here on the Q&A.
Okay, thanks very much, Alan. Okay, here's a question from John Pape, it says, do you think corporations will allow end-to-end IPv6 connectivity from the corporate intranet to the internet and abandon NAT and split DNS?
Well, I'll take a shot at that and say it's going to be end-to-end connectivity is IPv6. I mean, that is one of the main reasons. We don't want NAT anymore. So what this is going to mean is that your firewall guys are going to start really, really earning their keep. There's going to be a lot more complex firewall rules other than, you know, well, that's RFC 1918 space, so we don't let it out. Now with IPv6, there really isn't such a thing as RFC 1918 space. You know, there's private space, there's a number of other designations, and you know, there's unroutable space, but the way that IPv6 is meant to be used is end-to-end connectivity. So there's going to be a lot more policy involved in you know, the definition of the new policies as to what is allowed through and what is not allowed through and how that's actually done.
With that said, if I can add something though, as far as NAT implicitly gives you, this is one of the things NAT implicitly gives you is separate address spaces. But even within V6, with addresses that are theoretically globally routable, that doesn't mean your internal routing and, as Alan said, firewalls and configuration and so on has to allow that. You still have control over where the packets go. It just might look slightly different. And with respect to DNS specifically, split brain does not depend on having RFC 1918 space per se. It depends on being able to configure multiple addresses and multiple address spaces for your connectivity, which works just as well with subnets, and IPv6 was at least intended to make slightly easier in many ways. But I want to thank you for the question, because that seems like something we should have a good, succinct answer to. How do you do split brain in this brave new world? And I hope I'm asking Larissa to make a note of it, because I see a blog post in that. I see a knowledge base item in our new knowledge base at ISC, and I want to thank you for the question and hope you look soon for a more comprehensive answer to it, because it's a great question.
Yes, I'm also going to take note of the question and your contact information, because we're getting ready to implement views and split DNS implementation for Bind 10, and I think we want to keep this in mind. So with that, I think I've got all the questions. Colleagues, tell me if I missed anyone's question. I don't think so. Okay. If for any reason we did miss your question, you'll be getting emails from us later today, and please don't hesitate to write back. So I just want to give you one last piece of material here. This is our further reading list, and you will be able to look at these slides on our website and pick this up. There's references to the IATF drafts that we've discussed. There's also, so here's 2 IATF drafts, and then there was another page. Okay, I will make sure that I get it in there. There was an additional page of references, which seems to have been mislaid. The other place you can find references from us on IPv6 is the IPv6 solutions page at isc.org. So thank you very much, everyone, for attending, and I look forward to seeing you at future web seminars. Bye-bye.
Thank you, Larissa. Bye-bye.